Target 50. This target is a little bit challenging because you have to be able to look at the equation and decide what your answer is going to look like. For target 50, if the question only has x's in it, then we can just make an x number line like this. This is like an x-axis, so we can just make an x number line. Okay, so we can just do that because it only has x's in it, so we're going to get our answer on an x number line. Then if you look over here, this one has just x's in it. This problem up here has x's in it, so we're going to need an x number line. But this one has an x and a y in it. As soon as that happens, we need an x and a y axis. So there should be a y axis here also, besides just an x axis, but we should also have a y so that we can see what the answer is going to be on a graph, because this is going to have x's and y's. All right, so let's go back to the beginnings of target 50 and see what we're asked to do. So here it says find the boundary points. Those are of the inequalities. Draw the boundaries on the number line and then shade the solution region. Okay, you guys, what the boundary points are just like the x-intercepts. All right, you need to basically find when it equals 0 because that's the point where it hits the x-axis. This is our x number line. That's what we're going to be graphing. So for me, when I look at this, what I would do is I think about the equivalent equation of 2x squared minus 5x, and then if I bring this 12 over, I'd have minus 12, and then I pretend that it equals 0, because as soon as we have things that equal 0, we get to use the quadratic formula. So what I would do is go over to my calculator, and I would run that in quad formula, so program quad form, and I would use the 2, the negative 5, and the negative 12, and bam, I've got the answer of 4 and negative 1.5. So those are my boundary points because quadratic formula finds the x-intercepts for us. So where this thing would hit the x-axis would be at 4 and negative 1.5. So I go over here and I put one at 4 and negative 1.5. Now you notice I didn't put a dot, I didn't do anything because I have to then pay attention to the symbol. The symbol that I have here is a less than symbol. And going back to our inequality symbols, if we know those, with our less thans and greater thans, that's an open circle. With our less than or equal to or greater than or equal to, that's a closed circle. So I see that I'm going to have open circles, so I put open circles at each of those points, and then this is where you decide how you're going to shade. You're going to shade based upon numbers that work. The easiest number in America to test is the number 0. All right, so I test 0. 0 would be sitting here. Here's negative 1.5, here's 4. 0 is somewhere in between. So I take 0 and I plug it in for x. When I put it here, I'd have 2 times 0 squared minus 5 times 0 is less than 12. Well, is it? 0 squared is 0. 0 times 2 is 0. Minus 5 times 0 is 0. Minus 0 is 0. This whole side now becomes 0. Is 0 less than 12? Absolutely it is. So that's where I shade because 0 worked, and I shade in between there. Now to prove that that's the correct shading and correct answer is that I would then try a number like 5. 5 is over here. If I test the number 5 and I plug it in, 5 squared is 25 times 2 is 50. And then 50 minus 5 times 5 would be 25. That's 25. Is 25 less than 12? No! So I should not be shading over here, so I did shade in the correct spot. So this is what my graph would look like when I get the answer. And then my final solution would be negative 1.5 is less than x, which is less than 4, and it's shown in that graph. Right? This is the domain notation for that, writing that x because it's trapped between the negative 1.5 and 4. So if they have x's in it, you go to the x number line, you think about finding those x-intercepts and use those as your boundary points, and then you need to test. You need to test a spot. 0 is the easiest testing number. If 0 worked there, we should color it in. If 0 didn't work, then that would have showed us that we should have been shading out this way and out this way. But since 0 did work, we shade in between the two. All right, over here on this side, let's take a look one that has x's and y's. And if it has x's and y's in it, what I do is just like this one, I pretended there was an equal sign so I could figure things out. Well, if I pretend there's an equal sign here, then I would do y equals negative 2x plus 4, and I would just graph that. Well, that has a y-intercept of 4, a slope of negative 2, so I'd put a dot at 4, a slope at negative 2, and it's going to look something like that. Now, I got lucky on this one by drawing a solid line because this right here, if this is less than or equal to or greater than or equal to, that's going to be a solid line because it has that less than or equal to part. If it's just plain old less than, then it's a dashed line. So you need to be careful about that when you draw this graph. It has to be dashed if it's this kind or this kind. Solid lines come from less than or equal to, greater than or equal to. So solid is here because it's got this. So I draw a solid graph. And then I look at all the y values that are less than my graph, less than or equal to my graph. Well, an easiest point to test is 0, 0, 0, 0 sitting right here. If I try 0, 0, that means 0 for x and 0 for y. I'd have 0 is less than or equal to negative 2 times 0 plus 4. Well, that side is 0, and then it's going to be less than or equal to negative 2 times 0 is 0 plus 4. Is 0 less than or equal to 4? Heck yeah, it is. So I can color in this side over here. All right, and that's how I figure that out. Now, another common sense way to do that is just know that it's less than or equal to. Y is less than or equal to this whole graph, and all the y values that are less than this line are below the line, and it looks like that. Now, our calculators can handle that as well, so you can go y equals, and you can type in the equation. When you type in the equation, you go negative 2x plus 4, and it's going to graph the equation, but this means it's graphing it as a line. If I want to go over here, and I get my cursor on this, if I push enter, now it's a highlighted line. Now it's a greater than line because it's shading above it. Hit it again, that's a less than line. So that's telling me less than right there. It almost looks like a less than symbol. Now if I push graph like that, it's going to graph below the line and shade. So I push graph and it shades everything that's below that line exactly the way I did it by hand as well. So your calculator can handle inequality graphs if you know what to type and what symbol to get over here. Below the line is less than, above the line is greater than.